Today, we embark on a journey to understand Newton's first law of motion in depth. Newton's first law of motion, often called the law of inertia, states that an object in motion will stay in motion with a constant velocity unless acted upon by an external force. To truly grasp this concept, we must acquaint ourselves with inertia, the inherent resistance of an object to change its state of motion. Objects, whether stationary or in motion, possess this property. Consider this: when you slide a book across a table, it eventually comes to a stop. Why? Because external forces like friction, air resistance, and gravity act on it, gradually slowing it down. From the graceful dance of leaves caught in the wind to the familiar jolt when a car suddenly stops, the principle of inertia surrounds us, shaping the motion of objects in our everyday lives. Beyond our terrestrial realm, inertia plays a pivotal role in space exploration. Satellites orbiting the Earth, propelled by an initial force, continue their motion due to the absence of significant external forces like air resistance. Let's witness Newton's first law in action through a series of thought-provoking demonstrations, illustrating the persistence of motion and the role of external forces altering it. Understanding Newton's first law is not just an academic pursuit, it's the cornerstone of classical mechanics. It forms the basis for comprehending the behavior of objects in motion and is crucial in fields ranging from physics to engineering. For example, if you want to go on a distant planet, you don't need fuel for all the distance you have to cover. You just need to fire a rocket out of Earth's orbit, and it will continue its motion in a specific direction without any need of extra push of a propellant. A push will only be needed for landing and taking off. Rest of the way is just mathematics. You just have to fire it in the right direction, taking the gravitational force of nearby planets in consideration. Consider the safety features in cars, designed with Newton's first law in mind. Seatbelts, airbags, and crumple zones work together to mitigate the effects of sudden stops, keeping passengers safe. Now let's bring a little detail into attention. We humans are very quick at noticing change. Yet, if something has been happening for a long time, we cannot even feel it. If you accelerate on a car, let's say 10 meters per second, you'd feel all the thrill in the world, but at the same time, when we are moving across our galaxy at more than 800,000 kilometers per hour, we feel completely still while laying down. How mesmerizing! As we conclude this exploration of Newton's first law, let the elegance of its simplicity inspire further curiosity. The next time you observe an object in motion, remember the profound principles set forth by Sir Isaac Newton, guiding us through intricate dance of the universe. That's it for today. We will be back with another interesting topic